Okay, good morning to all. I'm going to start the topic. In the last class, we started the system of particles and rotational motion. In this, we discussed about the center of mass. Today also, I am going to continue the center of mass. Are you listening clearly? That you can write in the chat box if you have any problem, and while teaching, if you will get any doubt also, you can write in chat box. Okay, and now the topic is center of mass continuation. Right? Are you watching clearly? Anyone can type the message. Do it fast because before going to start, we have to check the connection. Is it clear or not? Yes, sir. Is it clear? Anish Kumar and Latika Pingua, right? Okay, the board is appearing and the voice is also clear. There is no problem in the streaming. Okay, in the class. Right. Let us start. I will start the class. That is center of mass. What is center of mass? In the previous class we discussed what is center of mass. Can anyone tell what is center of mass? What is center of mass? Can anyone give the definition of center of mass? Center of mass, it is a cm, right? Center of mass is a point where the entire mass of body is concentrated. The whole body mass concentrated at one point. That point is called as the center of mass. Center of mass is a point. Okay, previously I gave the definition also. Center of mass is a point where the entire mass of body is concentrated. Okay, the whole body mass concentrated at one point. That point is called as center of mass. Center of mass is a point at which entire mass of body is supposed to be concentrated. Entire mass of body concentrated. Okay, the whole body mass concentrated at one point. At that point, the body can balance it. Okay, that is the center of concentrated at the center of mass is a point at which entire mass of body concentrated is called as center of mass. Okay, that is the center of mass definition. And the next one is I gave the center of mass for some bodies. For the ring, where is the center of mass? For the sphere, where is the center of mass? Ring, sphere, rod, these are all geometrical bodies, means they have some regular shapes. In case of geometrical bodies, okay, in case of geometrical bodies, the center of mass is coincides with the geometrical center. Okay, in case of geometrical bodies, means geometrical shapes. Okay, in case of regular bodies, geometrical bodies, that means the geometrical body means that body has regular shape, that is a particular shape like rectangle or sphere, like that. Okay, in case of geometrical body, center of mass is at the geometrical center, right? Do you know what is the geometrical center of the circle? Circle center, where it is there? You know, this is the circle. For example, uh, I will tell where is the center of mass for the geometrical bodies. For example, this is a circle, circular plate. The center of mass is located at the center, like this. This is the center of mass. For example, this is a rectangular plate. Then where is the center of mass? Center of mass is at the point of intersection of diagonals. This is the center of mass. Like this, the center of mass for a rod, okay, cylinder. Let us consider this is a cylinder, okay, cylindrical rod. Center of mass is at the midpoint. Okay, these are all the geometrical centers, right? If you take a cone, okay, this is a cone, and this center is at a height. This is center of mass. The center of mass is at h by 4 height. H is the height of the cone. Like this, the center of mass for the regular bodies coincides with the center of mass for the regular bodies coincides with the geometrical center. Center of mass location we know. What is center of mass we know. The center of mass is a point in the body where whole body mass is concentrated, and if you want to suspend that body at a single point, you can suspend it like this. Okay, and this is about center of mass, and later we discussed about the center of mass in one dimension. Okay, and kindly the students, one uh, request from you, and if while teaching, if you will get any doubt, you can write in chat box. I am reading the chat box also. And one more point is that in the middle, if you have the uh, if the writing is not appearing or the voice is not clear, anything you can write in the chat box. Okay, and everyone should stay in the live till end. Okay, the few members are living in the middle, it is not at all good. Okay, and then these are the steps, these are the what basement for the 12th class. That's why if you are not reading and not following in the 11th class means, then the 12th class it makes more problem for you. Okay, right. Center of mass in one dimension, this is also we discussed, and within 1 minute I am going to start today's topic. Center of mass in one dimension. In one dimension, center of mass, what? Center of mass in one dimension, right? Center of mass in one dimension, how we can find out? That is, for example, there are n particles. A system has, system means one body. A system has n particles. Okay, a system has n particles. Their masses are n particles of masses m1, comma m2, and so on mn. Okay, a system has n particles. Okay, the system has n particles. Their masses are m1, m2, and so on mn. Are located on x-axis. One dimension means only one axis should be there. Are located at positions x1, comma x2, and so on xn on x-axis. On x-axis. Okay. Then the position of their center of mass. What is the position of center of mass? Then the position of center of mass. Can anyone tell what is the formula for the position of center of mass? We can take the position of center of mass as xcm. What they are telling, what we are giving it here, that is just simple. It is, this is the x-axis. Okay, this is x-axis. There are so, one system has so many particles. This is the first particle. It is located at x1 position. X1 means its distance from origin is x1. Okay, and this is m2 particle whose position is x2, means it is at x2 distance from origin. Okay, x1 here means this is x1 distance, this is x2 distance, like this. Okay, there is a nth particle is at here. There are so many particles like this, so many particles like this are there, and this is the nth particle. Its mass is the m suffix n. Its mass is the m suffix n. This is the nth particle. Its mass is m suffix n, and its location we can consider as xn. Like this, the positions of the n particles they give, and mass of the particles are give, and this is one body. The one body is on x-axis. It has n particles. Now the position of the center of mass. The whole mass of these all particles concentrated at one point. That point is called as the center of mass, and the position of the center of mass we can consider as xcm. Then what is the formula for the xcm? In the previous class we discussed, right? Xcm formula is m1 x1, you know this one, m1 x1 plus m2 x2, and so on mn xn. Mn xn by, we will get as m1 plus m2 plus and so on mn. Its derivation I said in the last class, and that video whatever I am taking the lecture in the YouTube, uh, even if you miss this lecture, you can if you have the doubts in the lecture, once again also you can watch, because it will be automatically stored in the YouTube. Okay, that's why it is one of the benefit for you. If you will take the class in the Google Meet, it cannot continue, it will not store, but here it will be stored. That's why it is a benefit, and you can watch once again also. And this is the formula for the position of center of mass. Okay, if you want to write this in a summation form, we can write like this. That is xcm is equal to summation mixi by m1 plus m2 plus mn. This is the summation of this is the sum of, in the downward, in the denominator, sum of a mass of all particles, it will be there. We can write this as the mass of system also. Okay, we can write like this. Okay, right, this is the formula for the center of mass, where capital M is the m1 plus m2 and so on mn. This is the sum of masses of particles. For example, this is a body. This body has many particles like this m1, m2, m3 and mn, like this. This the whole body mass is capital M. Then we write as capital M is equal to sum of these all particles mass, right? And this we can take as the mass of the system. Okay, we can take it as mass of system. Capital M is the mass of the system. Mass of system we can write. And the next, I'm going to explain one thing, that is the position of center of mass in two dimension. How we can write the position of center of mass in two dimension. Okay, right. And for that, I am going to erase this. You take the screenshot and write the notes. Okay, from this chapter onwards, regular notes you can write, and I will give the notes in the running only. This one is just like notes only. I am explaining, along with that I am also giving the notes for you, right? And now I am going to erase this. Now the next one is position of center of mass in two dimension. Okay, position of center of mass in 2D. Position of center of mass in two dimension. In two dimension, how to find out the center of mass position? Two dimension means two coordinates are there, right? X axis and y axis. Previously one dimension we discussed, only one coordinate, x coordinate is there. Now for that, now position of center of mass in 2D means, let us take n particles. We have a system. System means one body. Okay, a system has n particles. Okay, a system has n particles. A system has n particles of masses, n particles of masses m1, comma m2 and so on mn, and their respective positions, their relative positions. Their respective positions are x1 comma y1, x2 comma y2, and so on xn comma yn. Then the position of their center of mass. Okay, then the position of the center of mass. I want the position of center of mass. Position of center of mass also like this, it will be there xcm comma ycm. What position means, where is the center of mass? Okay, you look at here the diagram I will draw. For example, this is x-axis and this is the y-axis. There is a one system is there. This is a system. This system has many particles. This is m1 particle. This is m2 particle, and this is mn particle. Like this, so many particles are there in the system, and their locations are m1 particle is at x1 comma y1, and m2 particle is at x2 comma y2, and mn particle is at xn comma yn location. These all particles center of mass is at one place. For example, this all particle center of mass is at here. The location of the center of mass is xcm comma ycm. Okay, the center of mass location is xcm comma ycm. I want the position of center of mass. Then how we can write the position of center of mass? Then for that it has two coordinates, right? And xcm we write very simply, that is m1 x1 plus m2 x2 plus m3 x3, like that we can write. Okay, we write m1 x1 plus m2 x2 and so on mn xn by m1 plus m2 plus m3 and so on mn we can write, and so on mn we write. This is xcm, and if you want to write the ycm formula, we write as m1 y1 plus m2 y2. It is two dimension, that's why the two coordinates are there. And mn yn by we write as m1 plus m2 plus and so on mn we write. And now xcm comma ycm, if you want to write the position of center of mass, we can write like this, that is summation of mixi by, okay, this we write as xcm is equal formula we have, this we can write in summation form, summation mixi in the numerator, in the denominator mass of all particles gives the mass of the system, right? Capital M we write comma summation miyi by capital M we write. Okay, right, it was very simple. This is how to write a position of center of mass in 2D. And then how to write the position of center of mass in 3D, next one. Right here, little mistake I did. Oh, this is not Y3, it is YCM, right? It is YCM, YCM. Okay, and then I want the position of center of mass in 3D. Okay, position of center of mass in 3D. In three dimension, how to find out the position of center of mass? Means how to know the position, where is the center of mass? We have certain body, then where is the what is the location of center of mass? To find out the location of center of mass, you see here, listen very carefully. This is the coordinate system. This is one object. Okay, and this is in 3D. Let us consider in 3D, different part, the 3D, each particle is located with three coordinates. Okay, in three, to explain anything in 3D we require the three coordinates, right? And now let us see here, the system has n particles. Okay, and masses of particles we can take as, okay, m1 comma m2 and so on mn. System has n particles. Okay, and the particles masses are m1 m2 and so on mn. And positions of particles, where are the particles positions are, right? First one is x1 comma y1 is the position of the m1 particle. Okay, we have to write in 3D, because in 3D we require the three coordinates. Okay, with the three coordinates I have to explain. This is m1 is located at x1 comma y1 comma z1, and m2 is x2 comma y2 comma z2, and so on. Mn is located at xn comma yn comma zn, right? And the position of center of mass we write like this. The position of center of mass, how we will write? The position of center of mass we can take as their position of center of mass also three coordinates are there because it is 3D. XCM, comma YCM, comma ZCM. Okay, we can write here XCM formula. Just XCM formula is like this only there, M1 x1 plus M2 x2 and so on Mn xn by M1 plus M2 and so on Mn. YCM formula is same. ZCM formula we write as M1 Z1 plus M2 Z2 and so on Mn Zn by M1 plus M2 and so on Mn. Similar to this we have written. In place of Y we write Z. That's all. I'm going to write directly. That is the position of center of mass is XCM comma YCM comma ZCM is equal to we write as M1 X1 plus sorry direct in summation form I will write. No need to write this much lengthy. Right, we write as x coordinate as MIXI by in the denominator we have the sum of mass of all particles that we take as a capital M. Okay, and here we are considering that M1 plus M2 plus and so on Mn is the sum of mass of particles. This we can take as the mass of system. Mass of system. Okay, right. Then we here we write capital M, comma YCM we write as summation of Mi Yi by capital M. This summation, if you expand this summation term, okay, I is equal to 1 to n, we have to write. First, I plus 1, you have to write M1 x1. Summation means plus we have to keep. I in place of I2, you write M2 x2. Summation means plus, and so on like this. I equal to n, you write means Mn xn by capital M like this. The next one is summation we write as Mi Zi by capital M we have to write. This is the formula for the position of center of mass in 3D. In 3D, right? Till now we discussed how to find out the position of center of mass in one dimension, in two dimension, and in three dimension also. Let us discuss one or two problems. Then in that how we can find out the position of center of mass, that we will discuss. Okay, and you take the screenshot. I am going to erase this one, and if you have any doubt you can uh, tell me. Till now whatever that I explained, have you understood? Test the message. The first question is that 3 point masses of 1 kg, comma 2 kg and 3 kg are located at 1 comma 2 comma 0 comma minus 1 and 2 comma minus 3. Question is that calculate the position coordinates of center of mass. This is our question, and try to solve this question. Let us go for the solution. What they gave in the question and what we have to find out. 3 point masses are there. Okay, the masses are first one is the 1 kg. What is the position of the 1 kg? 1 kg is at position is the x 1 comma 2, and the second vertical is 2 kg. 2 kg at what position it is there? 2 kg is at x2 comma y2, right? That is 0 comma minus 1. The third mass is the 3 kg, right? What is the location of the 3 kg? 3 kg is located at x3 comma y3. That is nothing but 2 comma minus 3. Then what is our question? What is the position of their center of mass? Means xcm comma ycm is what? This is our question. We have to find out the position of the center of mass. How to find the position of the center of mass? In two dimension, they gave the positions of three particles. You see the question. 3 point masses 1 kg, 2 kg, 3 kg located at these three positions. Right? 1 kg located at 1 comma 2, 2 kg located at 0 comma minus 1, 3 kg located at 2 comma minus 3. That means three particles masses they gave and their relative positions they gave. And we have to find out the position of the center of mass. Then what is the formula for the position of center of mass? XCM is equal. We have the formula. That is, you know na very well? Yes, you know. M1 x1 plus M2 x2 and so on Mn xn. Mn xn by we write as M1 plus M2 and so on Mn we have to write. Now, here we have to substitute the values. You know M1. Here you see M1 is 1 kg, x1 1, M2 2, x2 0, M3 3, x3 2, like this. And from these given values that we have to substitute all the values, we will get M1 x1 1 into 1, 2 into 0. Sorry. Here we have only three particles now. We are not having the n particles. That's why the formula we will change now. This is the formula for n particles. But for three particles, how to write the formula? Only plus m3 x3 we have to write. I forgot and I wrote the formula for n particles. But we have only three particles. Then we have to write the formula for only three particles, right? M1 is 1, x1 is 1, M2 is 2, x2 0, plus M3 3, x3 2, and M1 plus M2 plus M3, 1 plus 2 plus 3. Then we will get 1 plus 3 2 just 6 by 6 you will get. Is it correct? How much value you got here? 7 by 6 you got here. Next, similarly, YCM if you want to find out. What is the formula for the YCM? M1 Y1 plus M2 Y2 plus M3 Y3 by M1 plus M2 plus M3 we have to write. Now you substitute all the values in this. Then if you substitute the values, what you will get? Yes, let us see here. M1 is what? 1. Y1 is what? 2. From where you got y1? You see this one, cursor you see in the given values. Y1 is x1, y1 is equal to 1 comma 2. Means y1 is 2, x1 is 1. Y2 is minus 1, y3 is minus 3. Then m2 is 2, 2 into minus 1. M3 is 3 into minus 3 by m1 plus m2 plus m3. 1 plus 2 plus 3 we have to write. Then if we will simplify this, 1, 2 minus 2, 0, you will get minus 9 by 6 we will get. It is nothing but the 3, 3 ja, 3 you will get. Then what is the position of their center of mass? The position of center of mass we got is xcm comma ycm, right? What you got here? 7 by 6 comma minus 3 by 2, right? This is the solution. Now let us go for the one more problem, and that uh, I will give the hint, then you try to solve that problem. Okay, now I'm going to erase this, right? Is it clear everything? Nehalata, Anish, Baby Mahato, test the message. Nandini, everyone, are you watching? Test the message. Is it clear? If you have any doubt, you can test. I'm waiting for you. Next question. Find the center of mass of three particles at the vertices of an equilateral triangle. The masses of particles 100 gram, 150 gram, and 200 gram respectively. Each side of equilateral triangle is zero point 0.5 meter long. 0.5 meter long. In the question that they gave the diagram also, or otherwise they gave the in the question the diagram also they gave. You see here what they gave in the question and what we have to do it here. Solution I will explain it here. In the question they give the diagram. You see this diagram. What is our question here? Find the center of mass of three particles at the vertices of an equilateral triangle. Then we have to find out the three particles center of mass. The three particles are at the vertices of an equilateral triangle. Three particles at the vertices of an equilateral triangle. Okay. And the masses of particles are 100 gram. First one is mass is 100 gram. Second one 150 gram. And second one is 150 gram. Third one is 200 gram. Okay, you see the figure. 200 gram is located at on the in the xy plane, and 100 gram m1 mass is located at origin, and m2 is located on the x-axis. M2 is the 150 gram. M2 is equal to 150 gram. Then these are located at the vertices of an equilateral triangle. This is an equilateral triangle in the figure, and at the at the vertices, at the edges, okay, three particles are there. This equilateral triangle has a side 0.5 meters. In the equilateral triangle, all sides are equal, right? 0.5 meters, 0.5 meters, 0.5. Then what is our question at here? In our question here, we have to find out the position of their center of mass. For example, the position of center of mass is at here. This is the center of mass. Then the center of mass position is xcm comma ycm, that we have to find out. Then firstly, before going to find out the position of center of mass, we have to know about the position of all particles. First one mass is what? M1 100 kg. What is the location of the M1 in the coordinate system in the figure? M1 is at the origin, right? By seeing the figure. Origin means 0 comma 0, and M2 is the 150 gram. 150 gram is on x-axis. So it they gave in grams, na? Not in kgs. We have to write gram. 100 gram. 150 gram is located on the x-axis. It is on x-axis means y0 it should be. It is on x-axis means y automatically 0. On x-axis at what distance it is there? You see the figure, the cursor is moving. On x-axis M2 is at 0.25, meter distance. Means M2 x value is zero point 0.5. M2 is on x-axis, that's why y is 0. Then we write as 0.5 meter comma 0 we write. Then the next, the third mass is 200 gram. What is the position of the third mass? The third mass position is x3 comma y3. Its position we have to know. Then how we will know its position? What is the, actually, for example, we see here we have to find out the coordinates of the third particle. This is the third particle. Okay, this the third particle coordinate we can consider as x3 comma y3. Then x3 is what? This is x3. Is it x3? Right? This is x3 on x-axis distance. This is y3. Y3 is the height of equilateral triangle, right? Then here we know y3 is equal to height of equilateral triangle. What is the formula for the height of the equilateral triangle? 3 by root 3 by 2 into a. Is it correct? Is it correct formula for the height of equilateral triangle? Height, height of equilateral triangle is root 3 by 2 a. A is the side, okay, and y3 is equal to height of equilateral triangle. Listen very carefully. This is the y3. Y3 is equal to h. H is equal to root 3 by 2a. Root 3 by 2 into a is what side? Side is the 0.5 meters. Then we will get as 0.25 root 3. Have you understood how to find out the y coordinate? Just for example, here one point is there. This coordinate I want to know. Then for that, what we have to do? We have to draw a perpendicular line to x-axis, perpendicular line to y-axis. This distance will become x, and this distance become y, and this is also y. This is also x. Right? This is x comma y. That means now from the figure, what is the y? This m3 is this one. You see figure m3. We drawn the vertical line and horizontal line. This distance on the x-axis is x3, and on the y-axis is y3. X3 from the figure we got a 0.25. 0.25 root 3, right? And y3 is what? Sorry. Y3 is the 0.25 root 3 because y3 is the height. X3 is what? X3 is the half of the this side. You see this half this side. X3 is this length. This length by 2 you do. 0.5 by 2 is the 0.5 by 2, comma. X3 we got. X3 equal to side by 2. Y3 is the height of equilateral triangle. Height of equilateral triangle we find out just now. That is 0.25 root 3. Right. Finally, we got the x3 y3. This is nothing but 0.25 comma 0.25 root 3, right? Finally here we got the positions of all particles and masses of all particles. Then what is our question? Position of center of mass is what? That means xcm is equal to y xcm, ycm is equal to what? Then we have to find out the xcm. Then three particle system. Then you write the formula m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. You know the values of m1, m2, m3, and you know the values of x1, x2, x3. You substitute, and ycm is equal, we will get as m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3 we will get. With this, our you substitute the values in this. You substitute the values in this. If you substitute, then you will get the answer. Okay, this is m3. Okay, this is m3, and you know all values. You substitute in this, you will get the answer. Okay, and write the answer in the comment box. Next topic I am going to explain. I'm going to erase this. Next topic is motion of center of mass. Motion of center of mass. In this, what we are going to discuss? In this, position vector of center of mass, position vector, comma, velocity, comma, momentum of center of mass. Okay, that we are going to derive. When center of mass moves, at that moment center of mass should have some position vector, center of mass should have some velocity, some momentum, that we are going to derive. Very simple. Let us consider this is a coordinate system, and we will take the n particles. This is a body, this is m1 particle, okay, and m1 particle, and this is m2 particle, and this is mn particle, and their locations are m1 is position vector is r1 bar, m2 position vector is r2 bar. You know what is position vector? Position vector means it is a line joining origin and particle. The m3 position vector will be like this there. This is r3 bar. Like this, a system has n particles. N particles, masses m1 comma m2 and so on mn, and relative position vectors, are r1 bar, r2 bar, and so on rn bar. These are the mass of particles and positions of particles. We can take the system mass is m. Okay, mass of system we can consider as capital M. Mass of system is capital M, means mass of system we will get as sum of mass of all particles, right? I want the position vector of center of mass, position vector of center of mass. We can take it as RCM bar. This we will get very simple. In the previous format we have tried M1 R1, M2 R2, and so on Mn Rn. This is the position vector. What is the position vector? The line joining one particle and origin. You see in the figure. This is the M1 is a particle. You join the particle and origin with the red line we join. This is said to be position vector. Position vector means it is a line joining from, it is a line joining the origin and it is a oh, M1 plus M2 and so on Mn we have to write. Okay, this is the position vector. We can also write this one like this. RCM bar is equal to, in the denominator we write 1 by capital M, and the remaining is M1 R1 bar plus M2 R2 bar and so on Mn Rn bar we write. In the denominator we wrote capital M, sum of mass of all particles gives the position vector. Okay, mass of the system. And next after this is the position vector. Velocity of center of mass I want. Velocity of center of mass is nothing but velocity is the rate of change of position vector. We write like this: velocity is the rate of change of displacement. Then we write as VCM is equal to d by dt of RCM. What is RCM? You see, RCM is in the previous equation. It is there 1 by capital M into M1 R1 bar plus M2 R2 bar and so on Mn Rn bar is there. Okay, and we have to write uh, all the constants outside of the differentiation. Okay, this capital M is a constant we write outside, small m one also we write outside. Then we will get like this 1 by capital M into, we write like this M1 into dr1r by dt. D by dt से multiply करिए. 1 by m constant we write outside. D by dt of M1 R1, but M1 is a constant we write outside. And M2 into dr2 by d2 we write. And then Mn into drn by rt we write, or drn by dt we write. What is this dr1 by dt? This is the velocity of center of mass. This one is written as v1 because this is the position vector of the first one. First particle position vector, rate of change of position gives the displacement. dr1 by dt gives the dr1. R1 is the position vector. Position vector by time. Position vector also gives the displacement. Change in position vector. R1 is the position vector. dr1 is the change in position vector. Displacement by time gives the velocity. Velocity of the first particle it will gives. M2 V2. Velocity of second particle. M1 Vn we will get like this. We will get the velocity of center of mass. Here we got the velocity of center of mass as, we write M1 V1 plus M2 V2 and so on Mn Vn. And in the denominator we can also write, if you want, we can write instead of capital M we write M1 plus M2 plus and so on Mn we write. This is equation 1 we will take, and this is equation 2, and this is equation 3 we write. Okay, and the next acceleration of center of mass I want. You see in the heading, position vector of center of mass, equation 1, velocity of center of mass completed. Next, momentum of center of mass and acceleration of center of mass also required. Then for that, what we have to do it here? I'm going to erase this. More 5 to 10 minutes, 5 minutes I will take the class. Don't worry. I'm going to close. What you got, the velocity of center of mass? Velocity of center of mass we got is that one. In the denominator we will take capital M. Left side we will take velocity of center of mass. You got is from equation 2, you see capital M left side, when you will take the left side, then capital M into VCM is equal, we will get, that is M1 V1 plus M2 V2. Capital M is the mass of the system, and M1 M2 Mn are the mass of the particles. Everybody is made up of the many particles. This M into VCM gives the moment total mass, velocity of center of mass. This gives the momentum of center of mass. It is equal to momentum of the first particle, momentum of the second particle, and so on, momentum of the nth particle. This is the formula for the momentum of the system, right? Equation 3 completed, equation 4, and the next I want the, from equation 3, okay, I want the acceleration of the center of mass next. Acceleration of center of mass. Acceleration of center of mass is ACM. It is the rate of change of velocity of center of mass, dVCM by dt. But what is the formula for the VCM? You know, previously we derived the VCM formula. Okay, 1 by capital M into M1 V1 plus M2 V2 and so on Mn Vn. This we can write from equation 2 only. Okay, right. Then next what we have to do? Acceleration of center of mass is equal to, we write in this 1 by capital d by dt is, with the d by dt you have to multiply, right? D by dt is what? D by dt is called as rate of change of velocity by time. Acceleration is equal to change in velocity by time. A equal dv by dt, you know. ACM is equal to dvcm by dt. Then d by dt is same, multiply kariye. Then what you will get? Okay, within 2-3 minutes topic is going to complete. You listen very carefully. dv1 by dt, few things you may not understood, even though you try to understood, and your doubts you should ask to me, and then after that you will get the clarification. Okay, and otherwise you will face the problems in the future. That's why I am expecting from you to try to get the clarity of every topic. And then here 1 by capital M into, we write m1 into dv1 by dt is acceleration, rate of dv1, v1 is the velocity of the one particle. Okay, and a1 we write, dv2 by dt is a2 we write, and so on, an we write. Then from this is the formula for the acceleration of center of mass. This we can take as the equation 1. Equation 5, we take capital M to left side, MACM is equal, we will get as M1 A1 plus M2 A2 and so on, Mn An we will get. Then MACM is the force on center of mass, we will get as F1 plus force on first particle, force on second particle, and so on, force on nth particle we will get. This force on center of mass is equal to, we write as, force are two types are there, internal forces and external forces. But internal forces cannot change the motion of center of mass. Internal forces means what? Forces between the molecules. Internal forces, due to internal forces object will not move. Okay, internal forces cannot change the motion of center of mass. Okay, motion of center of mass cannot change it. That's why we write here FCM is equal to, internal forces can be neglected. Okay, internal forces in center of mass not influenced. Force on center of mass is equal to, we write only external force, but this force on center of mass we write as MACM. Then external force, then we write here acceleration of center of mass is F external by capital M. Then center of mass accelerates under the external force. In this what we derived? We derived the formula for the, if the center of object moves, inside the object center of mass is there. If object moves, center of mass also moves. Center of mass velocity how to find out? Center of mass acceleration how to find out? Center of mass momentum how to find out? That formulas we discussed. Once again you write the notes. Once you write the notes and check that point to point, if you will get any doubt you can ask me. Okay, thank you for listening my lecture. Okay, and I'm going to close today topic. Thank you to all. And if anyone not give the attendance, give the attendance, I will note it.